So for part C of this problem, it asks us 0 to 8. So you have to watch out for the interval because they changed it on us. It was 0 to 5, 0 to 5. Now all of a sudden it's 0 to 8. What is the greatest number of fish in the lake? Greatest number. So that tells us we're doing a maximum. All right, so we're looking at an optimization on a closed interval. What we need to do is identify the critical points. Where does f prime change sign, or is it undefined? But what most people forget is we need to check the endpoints, and we need to create a table of values. So we have to say, what is f of A, what is f of B, what is f of C for each critical point, and compare them and see which one's largest, because that's the only way we can get an absolute max. It says the greatest number of fish in a closed interval, so that's an absolute maximum problem. So just getting a relative max is not good enough because one of the endpoints could have been one of the solutions. So one problem that we face with this one is for part C, if we simply consider the endpoints first, right? So let's consider the endpoints, which are t equals 0 and t equals 8. And let's say we consider them first, right? So we need to know what f of 0 and f of 8 are. But the problem is they never tell us how many fish are in the lake at any given time. All right, but here's how we're going to get around that. The question asks at what time is the greatest number of fish. It doesn't ask us how many fish that is, what's the greatest amount. So if you think about, we have some weird function, we don't know what it looks like, maybe it does something like this, who knows, all right? And so let's say it looks like this where f of 0 equals 0. So if we just assume f of 0 equals 0, then we would find a certain maximum. Maybe it's at the end point over here. Maybe this critical point is really higher. I don't know. That's what we're going to find out. But the important thing is that suppose f of 0 wasn't 0, then the whole function would just be shifted up or maybe down. And that would change the maximum amount of fish, but it would not change the time of the maximum fish. So the idea is we get to assume that f of 0 is anything we want it to be. So obviously we'll just assume that it's 0. So we'll assume f of 0 equals 0 because it doesn't change what time the maximum will occur. All right, then we can use that to find all our other values. So for example, when I go to find f of 8, what I have to do is say that that's equal to f of 0. So this is my accumulation formula again. So when I go to find these values like f of 0 and f of 8, they didn't tell me those. So I need to use, all I have is a derivative. So I need to use that accumulation form of the fundamental theorem. So it's integral from 0 to 8 of f prime of t dt. But now I have to really think about that f prime being the number of fish entering the lake, the rate of fish entering the lake, minus the rate of fish leaving the lake. All right, so now, again, though, I don't have to worry about it too hard because I have these functions in my calculator. So f of 0, we're going to assume is 0. And then what I'm going to do is just go, remembering that in my y equals, I already have E and L, they're in there. So I can just quit out of there and go math 9 for an integral. And we'll do integral 0 to 8. And what I'm going to do is just go variables, y variables, and we'll do y1 because that's my rate of fish entering the lake, and then minus variables, y variables, enter y2, my fish leaving the lake. So now I've just got integral 0 to 8 of y1 minus y2. And so I put that as dt, and then hit enter, and it gives me a value of 80.91. Now I might need the 0.920 and I might not. So let's just make a note of it so we know what it is. It's 80.92. That's doubtful that that will come into play in establishing the absolute maximum. All right, so these are our endpoints. Now we need to look at critical points. So in order to get the critical points, we need to know where f prime equals 0. That is to say where E of t minus L of t equals 0. So we're going to solve that graphically since it's a calculator active problem. And one easy way to do that is in my y equals. So I could, do various things like graph both of these and do an intersection, things like that. You could do that. Probably the easiest way to do this is create a new function that is y1 minus variables y vars y2. So I'm just going to make a new function that's y1 minus y2. Another thing I'm going to do to sort of clean up my graph is I'm going to turn these two functions off. So if I highlight the equal sign and just press enter, that toggles that function off. See how this equals is not highlighted, but this one is? It means this function is turned off. It's not going to show up in my graph. So I'm going to do that to both of them. Then I'm going to think about the window. So the window, I know that the interval they gave me was 0 to 8. I'm going to make sure I keep in -1 so that I get the y-axis on there. And I'm going to just go to 9 just because I like to go a little outside my interval with my window. I didn't really have a good sense on what these functions could be, but I know the most the e of t can be is 35. You know, so I just did -35 to 35 just because why not? But you might have to experiment with that a little bit. So when I graph that, this is f prime of t, so remember this is f prime. So we see a maximum here, that's not the maximum number of fish, that's the maximum rate of increase of fish. So where do I have a maximum value of fish? It's where f prime changes from positive to negative, right here. That's my critical point. So I need to find where that is. So I go second calc. I want to calc the 0, that means the x-intercept, yeah. So I want a left bound, so I'll put my left bound near by. It wants a right bound, so I'll put my right bound on the other side of the root. So the arrow's telling me we're looking in this interval. It wants a guess, that's a seed value for an iterative method. So the closer I put it to the actual solution, the quicker the convergence will be. And I get this number 6.204. All right, so I need to know what f of 6.204 is. All right, so that's going to be f of 0 plus the integral from 0 to 6.204 of f prime of t dt. Okay, now I'm going to show you how we can get that quickly, because when we go back to our screen here, so first of all, I already have an integral of that derivative. So let me just go up there and press enter, and that will copy it down to the next line. Now I can edit it. Now when I go up to the upper limit that I want to change, I'm not going to type in 6.204. I'm just going to press X because that value of 6.204 is already stored from my graphing solution. And then I just press enter and I get 135.01. So 135.01. You know, the technical requirement is 3 decimal places, 135.015, except that a numerical answer is not, this is not the numerical answer they're looking for. The numerical answer they're looking for is this one. So I compare my values. I have my 2 endpoint values and my critical point value. Now my endpoint values were not did not turn out to be solutions, but they are part of my justification. If I didn't have them, I would not get my justification credit for this, because I would not have shown that the maximum we found is an absolute maximum. We would only have a relative maximum. So I need these as part of my justification. Now you'll see, by the way, if you study the solution that is given by College Board, there's another way to establish that this maximum is absolute, which is by observing that the derivative is always positive for t less than 6.204 and always negative for t greater than 6.204. Therefore, this relative max had to be absolute. And so you can use that justification. I'm not going to, because it's sort of specific to this problem and it works for this problem. But if you had more than one critical point, or if your critical point were sort of shaped differently, it wouldn't be as effective. So I'm going to stick with, the very general method of find your endpoints, find your critical points, compare your values. And then we just need to state our conclusion and say that the maximum number of fishes occurs when t equals 6.204. If you want to put the units of hours, you may, but it does not ask for units. It just says justify your answer. And in this case, we're going to find that this table of values counts as a justification.